Hi, so I'm Pierre Gentin. I'm a director for LEAP, a new center supported by the National Science Foundation. And LEAP stands for Learning the Earth with Artificial Intelligence and Physics. And what we are trying to do is basically merging artificial intelligence and climate so we can better predict the future. So I started this enterprise, we could put it this way, a little bit, to be honest, as a bit of a midlife crisis, I was thinking, okay, academia is great, but at the same time, you want to see action, right? What we are trying to achieve in the center is going beyond just science, but transferring the science and putting that in the hands of the people so that they can actually act. So we are trying to lower the barrier so that everyone could get access to climate data across the globe. What we needed was to gather and to put forces together, right? We needed to be just more than myself. It needed to be like a big team, and some of the key players.
I joined LEAP because I am both intrigued by the challenge of the research and also the mission to develop a new discipline of climate data science. We see a lot of excitement from students that was beyond our expectation. They told us this has been things that they've been looking for. They want to learn from both the climate science side, they want to learn machine learning tools. From the computer science side, we see a lot of students, especially from those in the underserved community, they say they've been looking for the opportunity to apply their computer science skills to problems that are important for their communities.
When I was in high school, I wanted to be an astronaut. I was one of the first people to go to space camp in Huntsville, Alabama, and pretend to be an astronaut for 10 days. But then I realized how much we don't know about the ocean and the climate system here on Earth. Our goal is to use all the available data out there from sensors, from satellites, so that we can help everyone adapt to climate change.
I'm a climate scientist, and one of my jobs is to try to understand what's going to happen to the Earth due to climate change, due to rising greenhouse gases in the atmosphere. And to do that, we need to build a model of the Earth. Earth system model is a collection of mathematical models of the Earth system. So it consists of an atmosphere, ocean, land, sea ice, ice sheet, rivers, basically anything you think of, you name it, it's within this Earth system model. And so every scientist who's out there who's, say, measuring stream flow of Mississippi River, that scientist has very strong and deep ideas about what is controlling the stream flow, and we need to bring that in the model. And then there's also a person who studies the oceans, how phytoplankton grows and affects how the sun's rays penetrate into the ocean, and we need to bring that feature into the model. So everything that you can think about, it's sort of out there in nature that's been studied by scientists needs to get pulled back and ingested into our Earth system model so that we have a full and complete representation of the Earth system so that we can then predict it.
What do? I look at computer screens. I look at simulated clouds and I compare them to satellite clouds and I ask if they're similar, and often they're not. So you can see how clouds form in nature. You can watch it happen, right? Like the water vapor rises and then a lot of things matter. The water condenses around a little dust particle, and what the chemistry of that dust particle is matters. Whether it's organic and oily and wants to repel the water, or whether it's dissolvey like salt and wants to collect the water. And then other things happen that are really beautiful and complicated, and there's heat released as the water condenses and waves that ripple out, and then the droplets organize and they create patterns, and the patterns influence each other, and it all adds out to the beautiful thing we call a cloud. And you're never going to simulate all of that complexity. But what these clouds do as the climate warms is going to affect how hazardous my kid's future is. There's patterns in nature that we can't simulate yet on the computer, and that's where we work. We try to make it more and more of a plausible realization of the atmosphere so that we trust its predictions of the future more and more.
If we can have better predictions about what it's going to look like in the future, that helps us to sort of plan better today. I am a business school professor. This idea of climate change and of the importance of accurately predicting climate change is going to be so important for the business world, kind of especially as we fast forward into the future. So let's take, for example, a company that makes soda. A supply input to that soda is water. It's important to know things like water contamination, sort of what factors are that are going to influence where we can and cannot get usable water in the future. Well, if we had better answers to that question and we could say what this is going to look like in 5, 10 years, that would give us a better idea of, well, maybe where we should be building our operations right now. Having that information would help them make that decision today.
When we're thinking about the climate crisis, we have an understanding that not all people are being affected equally. We'll all experience the effects of climate change, but Black and Brown communities, lower income communities are more likely to be negatively affected and less likely to have the resources to combat things like extreme weather. So we believe, as with all science, that it's important to have a diverse range of backgrounds engaged in climate science work. There's knowledge and expertise in a range of communities that are also important for us to know and understand in order to do good science. So we're not only giving information, we're also building bridges and relationships that help us receive knowledge and information that we need as well.
LEAP is bringing together minds and capacities that simply haven't sat in the same room before. I'm a climate communicator because climate matters. It matters enormously. What we can say is that we're heading in a direction from vulnerability to resilience, a direction from exclusion to inclusion. And LEAP, I think, is a pioneer in this kind of effort. You'll be able to look confidently in 10 years and say, we're on a path now that's fundamentally different than the path we were on before.